So this is going to be the video for Chapter 4, Exercise 4. And what that question is doing is they're giving us a function. They're saying y equals f of x equals x squared minus 10x. And what they're asking us to do in Part A is to find the average rate of change of y with respect to x in the following intervals. And they're giving us some intervals. They're saying x equals 5 to x equals 6. That's the first interval that they've given us. The second interval that they give us is x equals 5 to x equals 5.5. And the final interval is x equals 5 to x equals 5.1. So these are the intervals. I would encourage you to write these down on a scratch piece of paper because I'm about to give you a formula that's going to help you solve this. So when you write down your intervals, what I want you to do on the first x, I want you to put a little 1 by it, so that'll be x1, and on the second x, an x2. In the second row, x1, x2, x1, x2. And that's going to give you the ability to keep track of the x's for the formula I'm about to show you. So for each one of these, the formula is going to be f of x2 minus f of x1 all over x2 minus x1. And so what that's doing is we're going to take, basically what we've done is we've made this bottom part here, this this x2 minus x1, that's essentially the h from the formula that we were using in problems 1 and 2. It's the change in x. It's how far we're going between x's. So in the first case, we're going from 5 to 6. Well, 6 minus 5 is 1. Those are 1 apart. In the second one, it's going to be 5.5 minus 5, which is 0.5 apart. In the third one, it's going to be 5.1 minus 5, which is going to be 0.1 apart. And then this here is essentially the f of x plus h, and this is the f of x. But if you fill in the blanks with this formula, we're going to make this work. So I'm going to grab a separate sheet of paper so that we can do the first one. So the first one we had was x1 equals 5 and x2 equals 6. So f of x2 minus f of x1 all over x2 minus x1. Well, what was our original f? We said that the original f of x was f of x equals x squared minus 10x. So for f of x2, we just need to plug in whatever we have for x2. In this case, it's this 6 here. We need to plug in that 6 for wherever we see an x. So f of x2 is going to be 6 squared minus 10 times 6. That seems pretty simple. I just plugged in 6 everywhere there was an x in my f of x. Now I need to subtract f of x1. I'm going to put parentheses around that because I'm going to have to distribute that minus sign at some point, and I don't want to mess that up. So f of x1, I'm just going to be plugging in the 5 this time everywhere there's an x. So that's going to be 5 squared minus 10 times 5. I've got those parentheses there just to be sure that I'm not forgetting anything. And we need to put that all over x2 minus x1. In this case, 6 minus 5, which is 1, which means we can technically get rid of it for this problem. The next step, the one where we're only going 0.5, we can't kind of get rid of that denominator because it's actually something that's going to make a difference. But for now, let's just simplify. So we've got 6 squared is 36, minus 10 times 6 is 60, minus, and I'm going to keep this all in 1 because we can use it again later. That f of x1 doesn't ever change for these, so we can figure out what that is and just plug it into the other two when we need to. So 5 squared is 25, and 10 times 5 is, well, negative 10 times 5 is negative 50. So we've got that going for us. 36 minus 60, that's going to be a negative 24. And then minus what's in these parentheses, well, 25 minus 50 is going to be negative 25. So we know from now on, anytime we have this f of x2 up here, oops, this f of x2 up here, getting used to my crazy camera setup, that you are going to have a negative 25. We don't ever have to figure that out again. So minus 24 minus a negative 25, well, that's plus 25. And if we finish that, our answer is going to be 1. All right, so what you do is basically on that first blank for A, you would plug in a 1. Now your numbers might be a little bit different, but the process is exactly the same. So for this one, we took our x1 and our x2, x1 and x2, and we plugged them into this formula that I gave you, f of x2 minus f of x1 over x2 minus x1. And basically we just algebra'd our way through the whole thing. So let's do that for the second interval. We'll get another piece of paper and do the second interval. In this case, if I can get a piece of paper, in this case the interval is x1 equals 5 and x2 equals 5.5. Okay? So we need to plug this back into our f of x2 minus f of x1 over x2 minus x1 formula. Okay? So let's remind ourselves what f of x was. F of x is x squared minus 10x. Now I'm just plugging in the values. I'm going to plug in the 5.5 to the first one here. So we've got 5.5 squared minus 10 times 5.5 minus f of x1. But we figured that out in the last step, and we know that f of x1 is always going to be negative 25. We don't have to do that again. So I've got 5.5 squared minus 10 times 5.5 minus a negative 25. And I'm going to trust you guys that you can do the algebra on this. If you do the algebra on this one, if you want to practice on this one and make sure that you're getting the right answer, oh, I forgot something. We need to put all of that over x2 minus x1. And in this case, that was 0.5, because remember 5.5 minus 5 is 0.5. So now I trust you guys to do the algebra. You're just going to plug this into your calculator. You're going to square the top, or square the 5.5 minus 55 plus 25 and divide by 0.5. And the answer you should get, if you're practicing on this one, is 0.5. That should be your answer for that interval. So let's do the last interval really quickly, set it up so you get one more chance to see how they're set up. And the way we're going to do this one, our x1 is 5 once again, and our x2 is 5.1. The formula is f of x2 minus f of x1 all over x2 minus x1. We're just doing the change in the function's value over the change in x, and that's kind of our way of guessing at what the limit might be. So I have 5.1 squared minus 10 times 5.1 minus that negative 25 that we figured out in the first step, and that's all going to be over 0.1. So you guys have calculators, you plug that in, and the math works out so that it is actually a beautiful 0.1. Oops, as I write 0.0. Don't pay attention to that. The answer is 0.1. So if you've done all of the math here, you should come up with that answer. If you didn't, shoot me an email because there's something going goofy with the calculations there. So there's something I want you to notice, though, about what just happened. Once you've filled in those blanks on your screen, you're going to see that for that first interval, when we did it for that interval where basically our h equaled 1, that denominator equaled 1, what happened is that the value equals 1. When our interval was 0.5, the value was 0.5. When our interval was 0.1, the value is 0.1. You might be tempted to think that that means something special, like the answer is always going to be whatever is in the denominator. That's not the case. It just so happens that the numbers that they set me up with for this problem do that perfectly. What's more important to notice is that these numbers are headed all in the same direction. They're going towards something. We're starting with 1, and we get a little bit smaller in this step, and we get a little bit smaller in that step. And that's because we're taking just this average rate of change. We're kind of guessing at it, and the smaller we make our interval, the smaller we make our h, the closer we're going to get to the actual answer. Well, what's the actual answer? That's actually kind of what we're hoping for. So that's part B. And in part B, they're asking for the instantaneous rate of change at y, of y at x equals 5. And so we've talked about in class that instantaneous rate of change, that means the same thing as derivative. That means the same thing as the slope of the tangent line at a point. It means the same thing as f prime. If you ever see like the f prime or the f double prime, those things all mean the same thing. And basically what it means for this homework is that we need to do the 4-step process on the function they gave us. So they gave us f of x equals x squared minus 10x. And we need to do the 4-step process. You guys know how to do that. There's actually there's a PDF file on the homework help site. If you're not sure how to do it, the first thing you need to do is the 4-step process. Once you've done the 4-step process, the answer you would come up with for this function would be 2x minus 10. So that's f prime of x, or the derivative of x, or the slope of the tangent line at a specific point. And they're giving us a point. They want us to plug in 5 for x. So we'll just do f prime of 5. And that equals 2 times 5 minus 10. Which, last time I checked, 10 minus 10 equals 0. And you'll notice that the numbers up here, when we were guessing this 1 and 0.5 and 0.1, we're all getting smaller and smaller, and it turns out that the actual value at that point is 0. So our guesses weren't bad, and the smaller we made our h, the better our guesses got. But ultimately, the correct answer here for B, for the instantaneous rate of change, is going to be 0.